In a previous video, I introduced passkeys and why they're important and the fact that they are going to be used all over the place for authentication purposes going forwards. So in this video, we are going to dive a little bit more under the covers, peel back the layers, have a look at a sample and understand how it works for both registering a new passkey as well as authenticating with an existing passkey that you've already set up. We're going to look at this from a browser perspective as well as what you need to build from an API perspective to support it. So let's go and dig in. Good morning, good afternoon, or good evening, whenever it is that I find you, and welcome along to the channel. So let's have a look at digging into some of this web authentication or passkey authentication mechanism. And to do this, I'm going to use this sample website application here, and I got this from this particular GitHub repository, so I need to give credit to those guys. But this one uses a Node.js backend. What I'm going to do is use an Azure Function backend for this, so I'm going to rewrite what they've done in Node.js and reuse the front end pretty much as they've used it here. So let's jump over and dig in and see what we've got. So I've got this kind of sample project set up here, and I've got a test page folder and I've got an API folder that at the moment doesn't contain any code at all. So the test page just consists of an HTML page, some CSS, as you can see there's not much in the CSS, and a JavaScript file. So the HTML is pretty much boilerplate, and as you can see there's a couple of buttons here around register and authenticate, and then when we dig over into the JavaScript, what we can see is on load we hook up events onto that register and authenticate buttons. But before we start digging into any of what goes on inside of this JavaScript, let's just go through a little bit of theory. So how does enrollment or creation of a passkey actually work? So the first step that we need between our browser and our backend API is we need to create a challenge. So we need a challenge API method that we can call, and a challenge is basically just a string. It's a string that comes back, gets stored in the browser, and it's used later on in the process to validate that the challenge is still the same challenge that originated from the server at the start of the process. So once we've got our challenge inside of our browser JavaScript, we can then call the navigator API and the credentials create method, and that goes off, and using some options it will go and create a passkey in the browser for us. And we could at this point, so these create credential options, that could be another API call that you want to implement if you want to keep all of those options server side, or as we're doing in this case here, we're just aligning the API's settings with our JavaScript settings that we've embedded, and you keep the two aligned that way. But it's perfectly possible to move that all server side so that you can manage that in one central place if you want to. And the key piece of information here is that the private key never leaves the device that's creating the passkey. So it never leaves your client machine or your mobile phone or your tablet or wherever you're running your browser. That private key never leaves that device. And once we've got that passkey, we then call an API again across to pass that passkey, but the public key only goes across in that call to our backend API so that that can be stored by our application server side for when you come to do the authentication side of it. So that part of the process, we validate the challenge. So again, we pass the challenge across at that point. We validate the origin that it's coming from. We check some flags that we've set in the credential options to make sure that that's all still consistent. And finally, we can store that user and the public key that's come across in our database or wherever we're going to store our credentials. And that is it for enrollment or creation of a passkey. So the variant of this is if you've got a roaming authenticator or some other device where you want to store the passkey. So if your platform that you're running on, say your Windows machine or your Mac, doesn't support passkeys storage, then you can use another device. And I did this in my previous video around showing you the functionality and capabilities of passkeys. You can store it on your mobile phone and have the device converse with your mobile phone via something like NFC or Bluetooth. So the difference between that, we still have our challenge method up front that gets our challenge. We still have our credential creation options that we need to do. The difference being that when we call the credentials create method API inside of our JavaScript, at that point it will initiate or use what's available to it, so Bluetooth or USB or NFC, to converse with your external or roaming authenticator, so your mobile phone, for instance. And your mobile phone will store the passkey, and then when you get to call the credentials, again, you go through exactly the same process that you went through before. So from an API perspective, it makes no difference whether the passkey is stored on an external roaming authenticator or on the machine itself. Your API is kind of unaware that that's all gone on. It still validates the origin and the challenge and stores the public key that gets sent across to the API. So let's dig into the code. So we're specifically talking about the register button click here. So here we've got our register button click method. So there we can see that we disable and we re-enable back at the end if there's any errors that take place. Then we call our get challenge, which is a method further down in the JavaScript, as we'll see. And if the challenge comes back okay, we then call a create credential method to go and call that API that we just spoke about in the slides. And then finally, if all of that goes okay and we actually create the passkey, then in this particular case, we're using local storage to store the public key, store the counter of how many times that credential has been used, and also store the credential ID. So if we come down and look at get challenge, as we saw from the slides, is just a REST call to an API method, so API/challenge in our case. And then the create credential method here goes through, creates those credential options as I spoke about. So again, this credential options object could come from an API call again if you want to, because it's just a JavaScript object that's being created here. So you could easily create that server side if you want to. And there's all key bits of information in here that you can read up in the web authentication specification if you want to find out what all these various bits and pieces are. So this is all about the relying party. So essentially your application that's making the call. This is information about the user that's actually making the call or creating the credential. So this is your user's real user ID. And then about which type of algorithms you support, and all sorts of other options and bits and pieces in here. The key point here is that eventually you get to a point where you call that navigation credentials API to create a public key, and you pass in those options that you've just created. And what that gives you back is this attestation object. And then the last piece of the puzzle is that you could pass that attestation object across to your credentials API to store that passkey or information about that passkey essentially. So everything that's inside this attestation object, like the ID of the passkey or the raw ID, and this client data JSON contains all the information that you need about the origin and the client side that's actually creating that passkey. So then just to carry on down, right at the bottom of our JavaScript, we've just got some utility JavaScript methods around base64 encoding stuff and changing array buffers to strings and strings to array buffers and bits and pieces like that. Some logging. And then we've got our RESTful method calls. So at the moment, a REST get will call my local host on 7071 with whatever API I need to call, so the challenge or the credentials call. And then I've got a post as well that will do exactly the same, but with a post. But at the moment we don't have any API in here, so let's go and create that API. So let's create And we'll do .NET 7 isolated. That should have given us the basis of our project. So now we need a few packages. So I'm going to add Newtonsoft JSON and JWT. Let's add the HTTP extensions for Azure Functions, and then the relatively new ASP.NET Core extensions, which I've also done a video on if you want to go and check that out. So in our program CS, we can get rid of worker defaults, replace that with web application. In our host.json, we can add in that we want debug level, and all of this comes from that other video that I did around the new ASP.NET Core extensions. Okay, and that's set up logging for us. And then the package that we're going to use for doing most of the heavy lifting of the web authentication or FIDO2 specification is this package called FIDO2.ASP.NET, and we specifically want to fix that at version 3.0.1 for now. There is a newer version coming that deals with the web authentication specification version 4, but this one works for version 3.0.1, and there's a lot in the version 4 spec that changes, so we're going to fix it at that version for now. So let's add a setting into our local settings for our Azure Functions to just say what origins we're expecting. And this is to do with calls and saying which callers or calling origins we're allowing to use our API. So it means that this API is going to be reusable from multiple different front-end client applications, and it will deal with calls appropriately, as we'll see. We'll also add a setting for our JWT secret, and that's it for settings, and that should be it for program CS. So let's close up some of that, and now inside of our API let's create a HTTP FIDO class. Let's just paste in the key points here of what we need. So creating a new class called HTTP FIDO, we've got our logging in it. We're going to hang on to an iFIDO2, which is from that library, the FIDO2 library that we just added. We're also going to hang on to a FIDO2 configuration, an iMetadata service. So all of this stuff is stuff that we're going to see as we go through and flesh this out. And then the this configs here, we need a config, a FIDO2 config for each different origin that can call into our API. So then we have our constructor that passes in some of that information from the dependency injection that we'll go and set up in a minute. And we hang on to all of those bits of information. So now to build on some of this, what we're going to do is get the JWT secret once only out of our environment variables. So that was the JWT secret that we just set up in our local settings.json. When you deploy this up to Azure, you'll obviously have to set up this JWT secret as an environment variable. So then, as I mentioned, for each different site that can call this particular API, we need a FIDO2 configuration. So that's what this thing is doing here. It's initializing that dictionary for every origin that is able to call into this particular API. So it iterates through that list of origins from the configuration down here. And let's just bring some of these usings in. So we set up our JSON serialization here and create a new configuration from the default configuration. And then we change a few things in that configuration. So around the origin, we replace that and the host, etc., etc. So that gives us a dictionary of origins that we can then map to a FIDO2 config. So now to our first actual API function. Let's go and add the challenge method in. So we have a new Azure function called challenge. That takes our HTTP request and our function context, and it's a get method. Here we deal with cause, so we look up the origin and make sure that it exists inside our list of origins. And if it doesn't exist, then we return back an error result, which we'll get to. So we can say there that it's a cause problem that's at fault. Then finally, the last thing that we do in terms of cause is send back the cause headers to say that we do allow that particular origin and we do allow get methods. And we return back our iAction result out of the method. The rest of the code is going to go in at this point here. But let's go and deal with this error response content. So let's go and add an error response content class. And this just contains information about what's going on. So nothing too sinister in here. The error message, any developer error message, what the request ID was, etc., etc. So now we've got that, we can return that back out of our API. The point of why we're using JWTs is that the challenge that we send back at this point needs to be validated, well, between calls to this particular challenge method and when we're trying to also authenticate or create a credential, which really means that we need to store the challenge on the server side. But I don't want to store the challenge on the server side. So if I send back a JWT, then that means that I don't need to store the particular challenge because it gets sent back in. I can just validate the JWT when it gets sent back in the later call and make sure that it's valid. So that's why I'm using JWTs for the challenge. But you can quite easily just store a string on the server side inside a session or anything like that. But obviously this is Azure Functions, so we don't have a session as such. So there's a few challenges around trying to do this with Azure Functions. Let's paste in the bit of code that's going to create our JWT for us. Create a JWT builder. We give it the algorithm that we want to use. We use our secret and various other bits and pieces, and then we encode that up. And if we get any problems, then we just return back another error response content saying that we couldn't create that JWT and we've had some horrible internal error. But that shouldn't really happen. So that's our challenge done and dusted. So let's move on and look at our credentials call. So this is where we're actually going to create our credentials. So we have to accept post and options because we're dealing with cause. So let's start looking at that. So we get the URI that's coming, or the origin out of the URI, and validate that against our valid list of origins that we support. And again, if we don't find that in there, then we return a bad object request that you're not allowed to use this particular API. And then finally in here we send back the cause headers that we need to make this call actually work. So that's the boilerplate code done and dusted. So let's go and deal with these red squigglies. So we need just a utility method under here for formatting the exception into a nice format. And then I also need that method to be able to extract out the origin. So that's this one here. So we use the origin header or the referrer header, whichever one has been sent in and whichever one it finds first. And whether it finds it as a header or a query string essentially is what that's all doing for us. So now let's move on to the actual implementation of this credentials call. Okay, so if this is not a cause request, then we call the library to go and create a new credential. And we have to do some jiggery pokery to make the library work with what we've got from our incoming request. So that's what this call does here, is it converts the incoming attestation into an attestation object that the library will accept. And then here is the bit around the JWT verification. So we go and get that JWT out from what's been passed in, and we make sure that that's all ties up with and is a valid JWT based on what we created earlier. If it isn't, we throw an exception. Then we set the challenge to that JWT in the library. This is a callback here, which, as it says, is around whether these credentials are unique to this user. So for the purpose of this exercise, we'll assume that that's true, that they are unique. But equally, you could poke into your database or whatever at this point for that particular callback to make sure that that is the case. And then last but not least, we then call the library to say verify this particular token, and if all goes well and we get back a success, then we pass back the credential ID, the public key, and also the number of times that it's been used back as a response. So now we need to go and fix up this particular convert for FIDO lib. So what we need to do is create a new class that deals with our particular attestation response that we get in, so that we can deserialize it correctly from the JSON that gets passed back to us. And then we're going to add this extra convert for FIDO lib, which basically creates an attestation response object that the library knows about, and we're going to populate that from what comes in our JSON. So that just maps those two things across to each other. And then the last thing that we need to do is back over in our program CS is go and add in the library so that we can figure that up. So inside of our configure services, we'll do services.add FIDO2, and we give it some options, and we're going to tell it what the origins are. So we use that environment variable, the origins, again to split those out so that the library is aware of the origins. And that should be that. We are good to go. And now we can run up our API. We see our two functions down there, and then I can use live server to bring up the HTML test page. Okay, so the first thing that we need to deal with is this red error that we're getting around that the platform authenticator is not available. So at the moment, as far as this machine is concerned, the only thing that's available would be a roaming authenticator. So in order to debug and help us simulate some things in the browser, what we can do is bring up the dev tools, and if you bring up this section here, you can see there's a web authn section. When you do that, you get a web authn tab appear here, and so then you can enable a virtual authenticator environment. And then what you can do is create, if I just raise this up, so I've got a couple that I've already created, but you can just go through and say that you want a CTAP2 protocol is typically always the one that you would use, and then you can say whether you want a USB authenticator, or you want to simulate Bluetooth low encoding, or NFC, or an internal one. As you can see here, I've got an internal one that I've already set up, and I've set a couple of flags, so yes to resident keys and yes to user verification. So I would have done internal and yes to that and yes to that, and then added that there, and that gives me this option here. So now with my DevTools open, if I refresh the page, you'll see that it now thinks that there is on-platform verification. So this particular platform that I'm running this browser on, so my Windows machine, does now have the capability to store securely passkeys, is what that's essentially telling us. What we can then do is, if I bring up the network tab over here, what we can say is we're going to store it in our platform authenticator, and we're going to authenticate using the last credential. It's irrelevant because we're creating a new one, and we click the register and we get a cause issue. So let's just jump back over and look at what we put inside of our local settings, and we did put HTTP for the origin. So let's just quickly change that, restart our API. So now when we hit register, we can see that we get a call to our challenge, which returns back our JWT. We get our options call to, which is our pre-flight check for cause for our credentials call, and then we actually make our credentials call, passing in all of that information that the WebAuthn API gives us back, so the client data JSON, the attestation object, etc. And that all succeeds and passes us back a credential ID, which is what we're seeing down here, the public key that we would store against that particular credential ID, and the number of times that it's been used, which in the case of a creation will always be 1. And in terms of our particular API or this sample, we also at that point store that credential information into local storage. And we've got various different trace information coming out down here so that you can dig through that and understand what's going on and what that looks like under the covers. Over in your authenticator, you get to see the ID that's been created. So this matches this and tells you that it's been created by that particular authenticator or authentication emulator in this case. So that's registration done and dusted. Now we need to go and look at how to handle authentication. So let's jump back over and stop all this. And then let's quickly jump back into the slides. So what's the process for authentication, or assertion as it's called in WebAuthn, or signing in with a passkey for us layman's? So we need to do that same challenge request and response so that we've got a challenge for this particular authentication. So that's the same method that we called previously, just gives us back our JWT in our case. We then call another method on the navigator credentials, which is a get, and this goes and gets our passkey from our device using the private key and the public key. And then we call another method on our API. In this time it's /assertion, but you can obviously call this whatever you want, but you need to make an API call at this point. And that API call is going to go and look at your store and retrieve that user and its public key. It's going to again validate the challenge that we did previously in the registration process, validate the origin again that we did before, checking flags that we did before, and then it's going to use the key to verify the signature of what's been passed in that assertion. And then finally we return that response if that is all correct and fine and dandy. So that is our process for signing in with a passkey. And again, we've got the same variant for if your platform can't support authentication with, or can't support passkeys on your particular platform, then you can use an external device. So that does exactly the same, gets the challenge, then calls credentials get, whereupon that would then use Bluetooth or NFC, for example, to go and get that passkey. And then we call the same assertion method that we would call for the other one. So back in our Azure Function API, underneath our registration method, let's go and add that assertion method. We've obviously already got the challenge. Let's go and paste this in. So again, we're doing exactly the same thing that we've done previously. We accept posts and options, and we're dealing with our cause stuff. So we've got all this that we've done previously from the other ones. And then we deal with cause by passing back the headers. So now to the meat and potatoes of it. Okay, so if we're not dealing with a cause request, this follows a pretty similar pattern to the registration. We deserialize our incoming JSON payload. We are going to override that to convert that into an object that the FIDO library can deal with. We validate our JWT, and again we've got another callback here, which for the purposes of this example we're just going to return true. But this is just making sure that the user owns the particular credential ID that's being requested. So again, you can do that in your data store and make sure that that all ties up. And then this is where we actually call the library to verify all of that information and run through all of the rules, checking the flags, doing all that stuff that we mentioned in the slides. And if that verify works, then we can return back a successful result and return back our credential ID and the number of times this particular credential has now been used for authentication, which we get back from the verify call. So we just need to go and fix up some of this and override the authenticator assertion raw response. So let's create a new one of those. Again, this is exactly what we did with the registration. So we're going to give it an object so that it knows how to deserialize our incoming JSON payload correctly. and then we create that convert for FIDO lib that basically moves all of that JSON information into the corresponding FIDO authenticator assertion raw response. So that now makes our function happy. So let's save this and run it up, and let's just clear out the console and the network so that we can see what's going on. So now when I hit authenticate, we can see our call to challenge comes across, and we get our JWT back, and then we make our call to the WebAuthn API that is querying in to our particular authenticator to get all the credential information out, and using the private key and validating all of that. And then when we say yes, carry on, that's the right user ID that I want to use. Then we see our call go across and our options call, so our pre-flight calls request, and then finally our actual call to the assertion, passing in all of that attestation data again, and we get our response back with our credential ID and the usage counter, and we can now see that the usage counter has gone up. So if I authenticate again, and we can see that that's stored inside of our local storage. So now if I do exactly that same process again, we see our usage counter goes up, and the usage counter inside of the emulator also increases. So it's all working across the board, and we can correctly now register a brand new passkey in our web authenticator, and we can authenticate using an existing passkey. So if we want to test the roaming, we can make our roaming Bluetooth low encoding transport the active authenticator, and then we can do exactly the same process. So we register there, and we see an ID gets registered in, and then we can authenticate using that, and it does exactly the same thing. So using that credential ID 64BQ, which is that one, which is this one, so all matches, we can see that again the authentication counter goes up every time we authenticate. There's a lot of stuff to that, but the FIDO library really helps us out in this regard. So the only thing that we want to do is also test. So this is using CORS, obviously, but if we don't want to use CORS and we want to make this all part and parcel of the same domain, then what we can do is we can simulate that inside of the settings. So inside of our live server settings, we can go and add another live server settings to say that we want it to use a proxy, and any calls to API go to localhost 7071 API. And if I do that, I can then come down inside of the JavaScript, and instead of hard coding that, I can assume that it's all part of the same domain. So I only need to pass the actual endpoint in the fetch call, not the full URL. So if I save that and run it all back up again, let's restart live server as well. So let's try and register a new credential, and we see that our challenge goes across and we get our call to credentials. And now if I authenticate, we get our prompt for Bob, and our challenge has gone in. When we continue that, we can see that we just get the assertion call. There's no pre-flight check now, so CORS has been disabled, and it all still works correctly with our as a function API. So where does this get us after we've done all of this? So what we've created here is we've got ourselves a reusable function API that we can run on Azure Functions, where we can test out from various different websites, because it's CORS compliant, the web authentication mechanism. So it gives you a nice sandbox environment, this, to go and play around and understand and try different things and see how you would want to implement web authentication on your particular website. So we have cut a few corners around these callbacks here, so you just need to be aware that this is not potentially a fully production strength API at this point. There are still some extra bells and whistles that you need to do around storing the credentials server side and that kind of stuff. But hopefully this gives you a better understanding of how WebAuthn works, and you can add that into your particular website. So with that, I just need to quickly thank my sponsors for their continued support of the channel. If you do want access to any of the source code, then you can become a subscriber to the channel and you'll get membership to all the repositories for all the tutorials that are on this channel. And that's it for this particular video. So I just want to say thanks for watching, and I'll see you in the next one.